Hi, welcome to another episode of I Can Alteryx That with coaches Alex and John. I'm John. Today, we're going to cover Alteryx Weekly Challenge number 228, Know Your Boundaries. Let's get started. Alright, so we've got what I think is a really fun and interesting weekly challenge this week. So our goal is to take this list, or the shapefile of US states, Minnesota, Wisconsin, Iowa, Illinois, Missouri, Kentucky, Tennessee, Arkansas, Mississippi, and Louisiana. Take the start and end points for the Mississippi River. You can see one down here at the corner, southwestern corner of Mississippi, and then up here, a little south of St. Paul and Minneapolis. And our goal is to take those files and generate this, an approximation of the Mississippi River. So I tried this for a while, and I came up with a couple different solutions, and I think this is, what I'm going to show you here is probably the most elegant that I could come up with. So the first thing that I noticed is the Mississippi River forms the border between Minnesota and Wisconsin, at least part of it, Iowa and Illinois and part of Wisconsin, Missouri, Illinois, Kentucky, Tennessee, and so on. But you notice states like Iowa and Minnesota, it does not form a border between those two states. So what I did is first I append the states themselves. Of course, we had 10 states to begin with, so that's going to give us 100 states. And we get things like this: Arkansas matching with Arkansas, Arkansas matching with Illinois, but those are matches that we don't really care about. So what I did is I went to the text input and I created a quick field or thing, a quick file here that's going to list all of the possible matches. So if you're not good with geography, I'll show the map again. So we're going to have a record that shows Minnesota and Wisconsin. And just to make things easy, I'm going to do all the states on the western side of the Mississippi River in my name field, and all of the states on the eastern side in my source name field. So we've got Minnesota, Wisconsin, and we've got Iowa, Wisconsin, we've got Iowa, Illinois. I'll go back to the map if you don't know your US geography too well. So then we've got Missouri, Illinois, Missouri, Kentucky, and Missouri, Tennessee. And do make sure you spell these right, because what we're going to do in a minute won't work if you have any typos. Okay, so there's our Missouri connections. Then we've got Arkansas bordering Tennessee, Arkansas bordering Mississippi. And finally we have Louisiana bordering Mississippi. So I'm going to join this into that appended data set. And this join is going to act as a filter. So we're going to join name and source name on both, and then we can deselect those right inputs. We don't need those. They're strictly acting as a filter source. But when we run this, instead of 100 records, we now only have 9. And that's going to be our 9 pairwise combinations of states that are bordering, that are, I should say, separated by the Mississippi River. So the next thing that we need to do, and this was probably something that's a little trickier that a lot of people don't realize, is that there is a formula, or a function, using the formula tool called st_boundary. So what I'm going to do is I'm going to take the boundary. Notice that, actually let me step back for a moment here. We have 2 spatial fields. You'll notice spatial OBJ is everything on the western side of the Mississippi, and source spatial OBJ is everything on the east side. So here, what I'm going to do is I'm just going to arbitrarily take the boundary of the east side. It doesn't really matter, and I'm just going to call it boundary. I could have taken the west side, just pick a side and stick with it. But what boundary does is it just simply converts that polygon spatial object into a line. And you can see here, our source spatial OBJ is a polygon, but boundary is simply a line. And that's going to become very important in the next step. So you can see there's our source spatial object. And now our boundary, you can see the difference is there's no highlighting with the boundary. So the next thing is we need to make an intersection. And the reason that I did this is the intersection between a polygon and a line is a line. If I had taken the boundary of both sides, the intersection of two different line objects is a point object, and we don't want that. We still want a line object. So I'm going to go ahead and grab this spatial process, and let's do the intersection between spatial object, the west side, and boundary, the line on the east side. And we're going to create an intersection object. So when I do that, and let this run, it shouldn't take too long. And the first time takes a little bit longer, but subsequent runs will be pretty quick. So we'll run this, and let's look at our spatial obj process field. And you notice on the surface it looks good. But when we zoom in, and this is what really caused me a lot of headaches doing this, when I zoom in, you just see all these little gaps. And that must just be because of the irregularities in the Mississippi River. It just twists and curves so much. And that one really tripped me up for a while until I looked at the output solution. And look at this. The output is a polygon. And this was the big clue that really helped me get this solution across the line. And so by looking, I say this is a polygon, I'm seeing, well wait, my boundary, let's go ahead and do something here with the boundary. So I'm going to grab a buffer tool. And what I'm going to do is I'm going to buffer out my boundary by about 1/10 of a mile. That seemed to be sufficient in this case. So now let's make sure we change our intersection from back to boundary buffer. And you'll see when you run this now, that the intersection, because the boundary instead of being a line is now a polygon that's 1/10 of a mile in breadth, that our spatial obj process now is a nice, smooth, continuous curve. So the next thing that I'm going to do is I don't care about Arkansas versus Iowa and Louisiana. They're all the same at the end of the day. So what I'm going to do is grab a summarize tool. We're going to take our spatial obj process and we're going to combine that. And I'm just going to call this boundary. So when you run this, we're just going to have the one record that shows that entire boundary and nothing else. So overall, this looks really good. The issue with what we have right now is that north of about St. Paul, the Mississippi River stops. It actually goes inland. So everything north of St. Paul is actually not the Mississippi River. And then obviously this flat line, the border between Louisiana and Mississippi, is obviously not the Mississippi River. So we need to take from about where my cursor is right now to up here. So that's where this other data set's going to come into play. So let's look at that. We have two records, one for end, which is the northern terminus, and one for start, which in our case is the southern terminus. So what I'm going to do here is crosstab. I want them to be on the same record. So we're not going to group by anything. I think we can actually leave everything in the default, and just make sure you choose an aggregation method. I'll just take first there. So now we have one record on this extra data set here. We have end in the south and start in the north. And I'm going to now append that to this data set up here. So we're going to have one record. It's going to have our boundary polyline, or it's actually a polygon, and then the source and end objects. And so this is these last few steps are where I feel that my solution is maybe not the most elegant, but I couldn't come up with anything that I feel is better. So let's look at what we have here. And I'm just going to focus down here. So you can see we have our polyline, or our boundary line. And then instead of being a point, the start and ends are actually these polygons. And so that's actually what I used to help me get to my final solution. So the next thing that I'm going to do is I'm going to split the boundary line into points. So now we're going to have discrete points that make up that boundary all along the way. And then what I'm going to do is I'm going to calculate the y coordinate, so the latitude of all of these points in my split spatial object field. And I'm going to calculate the same, just the y, the latitude for start, but I'm going to do something a little different for end. And I'll explain why in a moment. So let's go back and grab another formula tool. And I'm going to call this first field boundary y. And this is going to be st underscore centroid y. And that's going to be of my split spatial object. Make sure you set all of these to doubles. Then I'm going to do the same thing for start. I'm just going to call it start y. And this will be st centroid y of the start field. But I'm going to do something slightly different for the endpoint, that southern one. And I'll explain why I'm doing this once we run the workflow. This one, instead of st centroid, I'm going to do st max y of the end. Okay, so let's see what we've got here when we run this. Oh, looks like I messed something up there. Oh, I'm sorry. I was changing end when I should have created a new one called end y. That's why I didn't look the way I expected it to. And so we'll make a new field called end y. We'll do st max y. And this function, instead of taking the center point, is taking the most northerly point in that polygon. So let's run this and we'll see in a moment why I did what I did. Okay, so let that render for a moment. And let's go back down here, because this is where all the issues were for me. So my thinking is I'm going to take a filter and I'm going to say I want all of the boundary y's that are north of the end point, and I want all of the boundary y's that are south of the start point. The problem is if I took just the centroid of this end polygon, all of these points that are along the Louisiana-Mississippi border, this straight line, would still be showing up. But if I take the max point up here, then I'm eliminating all of these boundary points down below. And yeah, I'm getting rid of a handful of points that are actually on the river. But again, I couldn't come up with anything that I thought was a better solution. So the second to last thing, let's grab a filter. And this filter will be where boundary y is less than or equal to start y, that is south of the starting point, and boundary y is greater than or equal to end y, i.e. north of the starting point. And I'm just going to go ahead and do the last step at the same time. Since we split all those points out, let's go ahead and just combine them back together with a poly build. So we're going to build a sequence polyline. Our source field would be the split spatial object, and our sequence field is split sequence number. And when we run this, we should, 1, have our data filtered appropriately, and 2, have a nice, oh boy, what went wrong there? So what went wrong with my poly build tool? Let's make it a sequence polygon and see if that makes the difference here. And that makes sense because we had that buffer, which is a polygon. It might just be that we needed a polygon here. There we go. Yeah, so that was the issue. That because we had the buffer, which is a polygon, we needed to convert it back into a polygon at the end. And now looking between our answer and the final solution, I think we did a pretty good job. Not very many tools, a nice straightforward workflow. And that was a really fun one. That was a good challenge. I like the spatial weekly challenges. But there you go. That is my solution to Alteryx weekly challenge number 228. Thanks for watching. As always, thanks for watching the video. Don't forget to subscribe to the Data Coach channel for more awesome lessons on Alteryx and all things data analytics and visualization. Follow Data Coach on Twitter at AskTessellation and follow me personally at jemery_dataviz. Thanks again.